Hello, grade 12s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Abudewa Sos Ugobela Wemets. And without any further ado, let's look at these questions that we have here. Okay, so we have question 5 on exponential functions. It says the graph of f of x is equals to 3 to the exponent of negative x is sketched below. A is the y-intercept of f, and B is the point of intersection of f, and the line y is equals to 9. Okay, so we can see that we are given our graph here, and then 5.1 says write down the coordinates of A. So for A, we're just going to use the fact that we know that our A there is the y-intercept, so we know that we make x 0. So using this equation here, then it will be just as simple as saying 3 to the exponent of 0, and then we know any number expressed to the exponent of 0 is just 1. So therefore we have 1 there, and then our A is just 0 is 2, 1. Right. So always note that your A there, for a graph like this, it is always 1 unit above the asymptote. Right. So your asymptote in your x-axis line there. Now 5.2 says write down the coordinates of B. So to write down the coordinates of B, we can see that already here we have the 9, and then B is situated in the graph of f there, so we can use the graph of f to calculate the x coordinate of B. Then this will be f of x is equals to 3 to the exponent of negative x. In the position of f of x, we put 9, and then this is 3 to the exponent of x. Now remember, we are working with exponents, so we can write 9 in terms of exponents, base 3. That's 3 to the exponent of 2, and then 3 to the exponent of negative 1. Now we can see that the bases are the same, so that means according to our rules of exponents, we can drop down the exponents. So if we divide both sides by negative 1, or just mainly swap these ones, this will be x is equals to negative 2. But then our coordinates now will be B is 2, negative 2 is 2, 9, right? And that's how you would get your 3 marks, right? Then let's proceed. We have 5.3. It says write down the domain of the inverse. Note, we are writing the domain of the inverse. Now we know the relationship between the exponential graph and the logarithmic graph. Let's just analyze it here. When it comes to our asymptote here, so, okay, let's start with the intercept. When it comes to the intercept, just going to give you this. If we are working with the exponential graph, the x-intercept most of the time, if it is just a mother graph, it is always 0 is 2, 1. But then in a logarithmic graph, the mother graph of a logarithmic graph, the intercept will be an x-intercept, which will be 1 is to 0. Now, when it comes to the asymptote, we know that here for the exponential, we have our asymptote at y is equals to 0. But then here we have our asymptote at x is equals to 0. Now, when it comes to the domain of the exponential, based on this here, we can see that your exponential graph can move anywhere it wants in terms of your x values, right? So it can move to the left and right, and it is not restricted in any way. So that's x element of real numbers, but its range is y greater than 0. As we can see here, the graph must start above the asymptote. So we don't have the exponential graph below the asymptote, below the x-axis. But then what happens to our logarithmic graph? The domain here will be x greater than 0, because remember, the asymptote for the logarithmic graph is this y-axis line here. So the logarithmic graph never goes over to the negative x values. So hence we have our domain as x greater than 0, but its range will be y element of real numbers, because when it comes to its vertical movement, the logarithmic graph is not restricted in any way. So I just want you to observe this. If they ask for the domain of the inverse, and then you are working with an exponential graph, know that it is just the opposite of what you will have here in your exponential graph. So for the exponential graph, we say it's x element of real numbers, but for the logarithmic graph, it's x greater than 0, which kind of corresponds to the range here. Here, the range is the one that is y greater than 0, but the range for this one is y element of real numbers. So if you can check here, you can see an inverse in this. Here, there's element of real numbers for the domain, and then here there's element of real numbers for the range. Here there's y greater than 0 for the range, but here there's greater than 0 for the domain. So note that. And then all we had to do for 5.3 was to say that the inverse, we know that the inverse that they're talking about is the logarithmic graph. So what is the domain for the logarithmic graph? That's x greater than 0. So please note this somewhere in your book. It will come in handy. Then 5.4 says, describe the translation of f to h of x is equals to 27 over 3 to the exponent of x. Now, we can tell that this might be a little bit difficult for us to do because looking at this here, we can see that it is not the same as that. So if we want to comment on the translation, we have to make sure that this is similar to what we have there. So what are we going to do? We know that we are working with exponents, so all we're going to do is just apply our rules. There is a way in which we can bring this 3 to the exponent of x over to the numerator. It is just by taking this 3 to the exponent of x, but then right now we have a negative x here, and then multiplied by the 27, which just remains there in the numerator. Now, this is still exponent, so we can write 27 as 3 to the exponent of 3. And now, since the bases are the same and then we are multiplying, we know that we can add the exponents. So this is 3 to the exponent of negative x plus 3. Now, at this point, we can see that it is quite in the same format as that one. So that means now we can comment on the translation. Now we can clearly see what has been done to that graph. So they added 3 here, which is telling us that this graph here has been shifted 3 units to the left. Remember, we said if you see a plus here, then it means to the left. If you see a minus, then it means to the right. So that means we can now say f has been translated 3 units to the left. 3 units to the left to obtain h of x. So that is our conclusion there. That means f has been translated 3 units to the left to obtain h of x. And then we can see that by that plus 3 there. If it was minus 3, we were going to say f has been translated 3 units to the right instead. Right. So always note that. And then, okay, now we have 5.5. It says determine the value of x for which h of x is less than 0. So now, at this point, all we have to do now for the 3 marks, they say h of x is less than 0. But then remember, we've already broken down our h of x to be like this. 3 to the exponent of negative x plus 3. Then we're going to say less than 1. Okay, so they're saying less than 1, not less than 0. Pardon me for that. They're saying h of x less than 1 instead. Then, okay, now we have that 3 to the exponent of negative x plus 3. Now, the 1 here, we know that it can be written in exponential form as 3 to the exponent of 0, right? So, any number to the exponent of 0 is equal to 1. So, we can still write it in this form. But why is it that we want to write it in that form? It's because we want to apply a law of exponent that says if the bases are the same, then we can drop down the exponents. So now that the bases are the same, we can now say negative x plus 3 is less than 0. Now we can take this positive 3 over to that side. That's negative x less than negative 3. But then we know that we are looking for x, so let's divide both sides by negative 1. But what is the effect of dividing by a negative value when it comes to your inequality sign? Your inequality sign changes the direction, right? So right now you will have your inequality sign facing that other direction, then equal to positive 3. So always note that dividing by the negative value always changes the sign of the inequality sign. Okay, and that's how you were supposed to approach that question for a total of 12 marks. So make sure that you play the video as many times as possible and try to understand the approach that I took in solving this one here. With all that being said, guys, we've come to the end of the lesson. So please press the thumbs up button if you've enjoyed the lesson and then you found it helpful. And if you've been watching the videos and haven't subscribed yet, please hit that subscribe button. And if you are watching from Facebook, please like and follow the page and also leave a comment there. And do not forget to share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.